All right, today we're digging into one of the most critical decisions you can make when you're building any kind of smart device. It's a choice you make right at the start, but believe me, it shapes the entire future of your project. So, let's get right into it.
So picture this. You've got an idea for a great new smart product. What's the single most important decision you're going to make? Now your mind probably jumps straight to the hardware, right? You're thinking about the processor, the sensors, maybe the battery life.
But here's the thing. It's not the hardware. I mean, don't get me wrong, that stuff is obviously critical. But there's another choice that has a way bigger impact on how fast you can develop, how reliable your product is, and whether you can even add new features down the line. It all comes down to the software foundation. Are you going to program directly on the bare metal? Are you going to use a real-time operating system? Or do you go all in with a full-blown OS like embedded Linux? This one choice, it defines pretty much everything. You know, to really get this, let's build a product together. We'll make it up. Let's call it the Smart Pod. And we're going to start super simple. It's just a device that reads a temperature sensor. That's it. And for a job that simple, we're going to start with the most direct approach there is, bare metal.
So what is bare metal programming? Well, it's exactly what it sounds like. Your code is talking directly to the hardware. There's no OS, no middleman, nothing getting in your way. You are in total and complete control, managing every single clock cycle, every register, all by yourself.
Here's an analogy. Think of it like a single chef in a kitchen. They get an order, they cook it, they serve it. Only then do they move on to the next order. For simple, one-at-a-time tasks, this is incredibly efficient. It's fast, it's direct, no overhead. And the code for this usually looks something like what's called a super loop. It's basically just an infinite loop that does one thing after another. It reads the sensor, it processes the data, maybe it blinks an LED, and then it just repeats forever. It's simple, it's predictable, and honestly, it's perfect for a device that only does one thing. But what happens when things start to get a little more complicated?
Because this is where our super simple approach really starts to show its cracks. See, our SmartPod is a huge hit, and now, of course, the product manager wants to add more features.
First up, let's add a display to show the temperature. Okay, our super loop can probably handle that. It's getting a bit busier, but it's manageable. Our chef now has to cook the food and write the order on a ticket.
Okay, next feature. Let's add some buttons so the user can change the settings. Now things get tricky. Our loop has to constantly stop what it's doing to check if a button's been pressed, and that takes time away from everything else. If we miss a button press while we're busy reading the sensor, the user gets frustrated.
And here it is, the final straw. We need network connectivity to send data to the cloud. A networking task? Well, that can take hundreds of milliseconds to finish. And while our super loop is busy trying to connect to Wi-Fi, guess what it's not doing? It's not reading the sensor, it's not checking for button presses, it's not updating the display. The entire system just grinds to a halt. Our poor single chef is totally and completely overwhelmed.
Okay, the super loop is broken. We just can't do one thing at a time anymore. We need to juggle multiple, competing tasks all at once. We don't just need a chef, we need a conductor for our orchestra. And this is exactly where we bring in a real-time operating system, or an RTOS.
Now, the most important word on this slide is deterministic. An RTOS is a really lightweight OS, and it's designed specifically to manage a bunch of different tasks and, this is the key part, guarantee that the most critical jobs get done on time every single time. It is all about predictability. Let's go back to our kitchen. An RTOS is like hiring a head chef. Now, the head chef doesn't actually cook anymore. Instead, they manage a whole team of specialist cooks. They make sure the steak, that's our high priority task, gets seared at the absolute perfect moment. Even if it means telling the person prepping the salad, our low priority task, to just wait a couple of seconds. But in these kinds of systems, not all deadlines are created equal. And that brings us to the difference between hard and soft real-time. Think about it. In a hard real-time system, like a car's airbag, missing a deadline by even a tiny fraction of a second is a catastrophic failure. Period. But in a soft real-time system, like a video streaming app, if you miss a deadline, you just get a dropped frame. It's annoying for sure, but it's not a disaster. An RTOS is absolutely essential for guaranteeing those hard real-time deadlines.
Okay, so our smart pod is now this sophisticated, connected device, all thanks to our RTOS. But what if we want to take it even further? What if we want to evolve it into a full-blown smart home hub, with a beautiful graphical user interface, its own web server, maybe even the ability to run apps from other companies? Well, that requires a whole other level of power and complexity. And this is where embedded Linux enters the picture. Look, this isn't just a simple task scheduler anymore. It is a full-fledged operating system. It's got powerful features like virtual memory, which is amazing because it protects tasks from messing with each other. Plus, it is this massive, pre-existing ecosystem of drivers, networking stacks, and software libraries for pretty much anything you can dream of.
So, to complete our analogy, embedded Linux isn't just a head chef, it's the entire restaurant. You've got the kitchen, which is like the kernel. You have the front-of-house staff, those are your user applications. And you have management running the whole show, that's your system services. And crucially, if there's a problem in one department, let's say a waiter spills a drink, it doesn't shut down the entire kitchen. That memory protection is absolutely key.
Okay, so we've walked through the three main approaches. We started with our single chef, then we hired a head chef, and finally, we built an entire restaurant. Now for the most important part, how do you choose the right one for your project? Well, this decision matrix really breaks it all down. If you've got a simple, single-task device where you need absolute control and minimal overhead, bare metal is perfect. If you have a more complex device with multiple, time-sensitive tasks, an RTOS gives you the structure and predictability you absolutely need. And for a really complex device that needs a rich user interface, advanced networking, and all the power of a full OS, embedded Linux is the way to go. Just be prepared for a much steeper learning curve and some beefier hardware requirements.
And why does getting this decision right matter so much? Because the embedded systems market is absolutely exploding. It's projected to grow from over $110 billion today to almost $170 billion by 2030. Seriously, from your car to your coffee maker, these systems are everywhere. And the demand for engineers who really understand these foundations is just higher than it has ever been. When you get right down to it, it's all about this. The technology firm Witekio puts it perfectly. The wrong foundation adds friction. The right one sets your team up for faster delivery, fewer bugs, and easier updates. It's just like building a house, right? If you get the foundation right, everything else you build on top of it is stronger and a whole lot easier. So the next time you use a smart device, or maybe when you're dreaming up your own, think about this foundation. Every single intelligent system out there is built on one of these three choices. The only question is, for your next big idea, which one will you choose? Thanks for joining me.